Good evening, and a rather belated Happy New Year. I'm going to divide this program into two parts. A look round the sky, as we often do, and also give the results of the picture competition that we announced last year. And it's a good thing to begin, I think, with planets. And of the two inner planets, Venus is that very brilliant object now visible in the west after sunset. The other inner planet, Mercury, isn't actually on view this month, but it was recently. And here's our first picture, taken by Graham Senegal from Sale, and that's a rather nice view of Mercury in the evening sky after sunset. I may say the best way to locate Mercury is to sweep around for it with binoculars, but please don't do that until the sun's actually below the horizon, or you might look at the sun by mistake. Jupiter is also nicely on view now. It's in the evening sky, and here's one of several photographs sent in by John Fathers of Oxford, who uses a C8 celestron, and this was a 60-second exposure. Obviously, Jupiter itself is overexposed, but that was deliberate because what he wanted to do was to bring out the four major satellites, the Galilean moons, and there they are. And we know that the pioneers and the voyagers have told us they're very odd worlds indeed. But Jupiter itself is shown in this photograph by Mr. Fathers. You can see there the two main equatorial belts. The great red spot isn't actually on view there, and at the moment the red spot is not visible. But you can see the area where it should be, the red spot hollow, and I made a drawing of that with my 15-inch reflector, actually on New Year's Eve under rather good conditions, and you can see the hollow there to the upper left. But no doubt the great red spot will come back in the fairly near future, because it always does. John Fathers also took a photograph of the other giant planet, Saturn, which isn't well placed as yet. It's low down in the southeast before sunrise in the constellation Sagittarius, but the rings are wide open, and we'll see Saturn well later in the year. In that picture, you can just about see the Cassini division, which divides the main ring into two. But the Voyagers have sent back spectacular pictures of the kind you can't get from Earth, and I'm sure you remember that Voyager picture of Saturn's ring system. We had no idea it was like that. Obviously, one of the favorite subjects for astronomical photography is the moon. And the moon is quite easy to photograph, but not nearly so easy to photograph really well. And this is a rather interesting compilation by D.W. Wishes of Fareham, showing the moon at various stages over what I think must be Fareham Station. But John Fathers has sent in a picture of the full moon, and this is a very good one. But of course, at the time of full moon, the sunlight is coming almost straight down, and there are virtually no shadows inside the craters. So all you can really see are the bright and dark areas. And over to the right there, we see the dark plane of the Mare Crisium. And look over to the left, near the limb, and you'll see the dark spot marking the walled plain Grimaldi. But you see the craters better when the moon is away from full. And we have a picture of the three-quarter moon sent in by our youngest competitor, Michael MacDade of Birkenhead. He's 16 now. He was actually 15 when he took that picture. And you can see the craters well there along the terminator near the top of the picture, which is the boundary between the daylit and the night hemispheres. Michael Goodall has sent in a photograph of a very thin crescent moon. There it is, and you can just about start to see some of the features coming into view. But they're clearly better seen when the crescent is thicker, and this picture by Harry Hayward again shows the Mare Crisium very well. There it is, above the center of the picture, over to the right-hand side. But near full moon, the entire lunar scene is dominated by the rays. And here's a picture of the area of the greatest ray crater, Tycho, again sent in by Michael Goodall. And there's Tycho, almost in the middle of the picture, 54 miles across, with a central mountain and that system of rays coming out of it. And if you look near the top of the picture, you will see one of the largest wall plains on the moon, Clavius, over 140 miles across, with a kind of arc arrangement of craters inside it. We've had some very good pictures sent in from Holland by Hubert de Groot. And one of these shows what I think is about the most magnificent crater on the entire moon, Theophilus. And there it is, near the bottom of the picture, 64 miles across, 18,000 feet deep, with high terraced walls. And adjoining that is the grey plain of the Mare Nectaris, and on top of that, the great 75-mile bay, which is called Fracastorius. And note how the seaward wall of that old bay has been broken down by the lava, and now you can hardly trace it at all. Another fascinating feature is the Alpine Valley, shown here in this photograph by Tony Pacey. Near the top, we see part of the Apennine Range and three major craters, The shadow-filled one is called Archimedes, and that is 50 miles across. And the Alpine Valley is near the bottom of the picture, slicing through the Alpine range. It's 80 miles long. There's nothing quite like it anywhere on the moon. And we also have a picture of that from Hubert de Groot, which shows it excellently. And there it is, as you can see. And there again we have Archimedes and his two companion craters. And there too are the Apennines, and this was the area where Apollo 15 came down, in the Apennine foothills. And in fact, at this moment, in that area, there is standing a moon car, and the bottom part of the space vehicle that they used as a launching rack when they blasted away. And no doubt someday, someone's going to go there, put new batteries into that moon car, and drive it off. There's no reason why they shouldn't. But neither the moon car nor the bottom part of the rocket can actually be seen from Earth at any telescope. They are too small, but they are still there. The moon was new on January the 19th, and there's going to be something interesting on the 27th, because on that day, or the evening, the moon is going to pass in front of the star cluster of the Pleiades, or Seven Sisters, and cause some rather interesting occultations as it passes in front of the individual stars. And so occultation observers, such as myself, are going to have rather a busy evening on January the 27th. Now, from the moon, let's turn over to the sun. And here, of course, there are dangers, because I say yet again, never look straight at the sun through any optical appliance, and that includes a camera lens. So photographing the sun is quite tricky. But John Fathers has sent in a nice picture of sunspots. There they are. The sun, remember, is now past its minimum of activity. It's getting more active again, and we may expect more spot groups in the coming years. And there's one that Mr. Fathers actually photographed last October. At the moment, there are 4 small groups on the disk, and the next solar maximum may be expected around about 1990, 1991. We can't be quite sure because the sun is by no means perfectly regular, but we should have more sunspot groups in the near future. Let's turn now to the stars. And all through the winter and early spring, the dominant constellation is, of course, Orion the Hunter. And you can't mistake Orion with its 2 bright leaders, the orange-red Betelgeuse, and the brilliant white Rigel, and the belt and the sword. And Graham Sinigola has given us a very nice picture of Orion rising over one of the radio telescopes at Jodrell Bank. And there's the configuration, the orange-red Betelgeuse upper left, and the brilliant white Rigel to the lower right, and the 3 stars marking the Hunter's belt. And near the belt is the Orion sword, and inside that is the Great Nebula in Orion, shown here on this photograph by Hubert de Groot. And this, remember, is a mass of dust and gas in space, a stellar nursery where fresh stars are being created all the time from the interstellar material. And that one is over 1,000 light years away. But you can see it quite clearly with the naked eye. All you have to do is to look below the Hunter's belt, and there you will see the misty patch of the sword, and inside the sword is the nebula. Binoculars show it well, and telescopes give a really spectacular view. But what your telescope will not do is to show the colors. They have to be photographed, and here's one of John Fathers' photographs of the Orion Nebula. You can see there are not only the bright gas, but also some dark material. And there are dark nebulae in the sky. They're just the same as bright nebulae, except that there are no stars in or near them to make them shine. And the best example of a dark nebula is above the sword, below the bottom star of the belt, and is known as the horse's head. And this picture by Anthony Ward does show it. You can understand why it's called the horse's head as we come into it. It really does resemble the head of a knight in chess. And that, I think, is the most spectacular of these features. You can photograph it, as he's done here, although I must say that when you're looking for it visually with a telescope, it's very difficult indeed to find because it is pretty small. Adjoining Orion is a very much fainter constellation, Monoceros, the unicorn. There's not very much there with the naked eye, plenty of faint stars, but there's one fascinating nebula, and this is called the Rosette Nebula, and Anthony Ward has sent in a picture of that. It's a 20-minute exposure, shows it very well indeed, and of course the camera had to be guided to compensate for the Earth's rotation. And there are many ways of doing that. You can hand guide it, that's not very easy. One method that I very often use is to mount my camera on my driven telescope and then simply use the telescope as a guide, and you can get good results that way. Another feature worth photographing is the sword handle in Perseus, not to be confused with Orion's sword. This is a double cluster, a pair of open clusters in the same binocular field, and that picture is by Michael Oates of Prestwich. They really do make up a magnificent sight. But all these are inside our own galaxy. And as we know, there are many, many other galaxies, some of them spiral. And there's one in the Great Bear, or Plough, which is almost overhead in the evenings now. There's the familiar Plough, Mizar, the double star with the companion Alcor, and telescopes show that Mizar itself is double. And here is the spiral galaxy Messier 101. Not very bright, but well photographed by Don Iris with his 10-inch reflector, and this again was a 20-minute exposure. And as we look more closely at it, you can see the spiral arms very well. And if we were millions of light years away from our own galaxy, our galaxy might look rather like that. We've had many other pictures sent in over the past few months. Some of them, of course, are summer objects, so let's now take a look at one or two of those, and these are again by John Fathers. First of all, the autumn group of the square of Pegasus adjoins Andromeda, and in Andromeda we find the nearest of the really big outer galaxies, Messier 31, the Andromeda spiral, just over 2 million light years away. And there it is. It really is a spiral, but unfortunately it's almost edgewise onto us, and so the full beauty of the spiral is lost, which I think is a great pity. Then in the summer sky, the summer triangle is dominant, Vega, Deneb, and the other star Altair. And Vega is almost overhead during summer evenings, a brilliant blue star, the position occupied during evenings at present by the almost equally bright star Capella. And in Lyra, near Vega, is what we call a planetary nebula. This is Messier 57, and John Fathers has photographed it. Looks rather like a small luminous bicycle tire, and you can just about see the central star. And the name Planetary Nebula is not actually very good, because the thing is not a nebula and isn't a planet. What's happened is a very old star has thrown off its outer layers as it dies. But not all planetaries are symmetrical. There's one in the same general area, actually in the constellation of Vulpecula, the fox. This is Messier 27, and when you see John Fathers' photograph, I think you'll understand why it's often nicknamed the dumbbell, probably the finest planetary nebula in the entire sky. Then, close to Deneb, the leader of Cygnus, we have what's called the North America Nebula. This is not a planetary nebula, it's a gaseous nebula, and again, a photograph by John Fathers, and it really does look a little like the picture of the North American continent. During the last few months also, of course, we've heard quite a lot about Bradfield's comet. I think it may have been brighter than Halley's comet as seen from here, and there's a very fine photograph taken by Ron Arbour. But I'm afraid the comet is going away now. It's still in view, but it's getting fainter all the time, and it won't be back for a great many hundreds of years. Well, those are some of the pictures we've had sent in for our competition. We are very grateful to you all. I didn't try and judge them myself. We've called in our photographic expert, Douglas Arnold, who knows a great deal more about photography than I do. So, Douglas, what about the winners? What's your verdict?
Well, there were some very good pictures there, Patrick, and it was difficult judging amongst them. I found that the best thing to do was to select subject groupings and award a prize for each of those. So number one is, for the moon, the picture of Archimedes' crater by Tony Pacey. And I do agree with you very much, Patrick, that it's relatively easy to photograph the moon reasonably well, but it's very much more difficult photographing it really well.
Well, congratulations, Tony Pacey, and your prize is a copy of the Astronomy Encyclopedia.
Now, very close to that first prize was the second prize by Tony Ward, his picture of the Horsehead Nebula. And again, I must agree with you, Patrick, that nebulae come in all shapes and sizes and all intensities. The Horsehead Nebula is one of the more difficult to photograph.
It's very difficult to see also with the telescope.
Indeed.
It is. Anyhow, his prize is a copy of your own book, Images from Space.
Now, the third prize, Patrick, John Fathers, who sent in quite a lot of pictures, as we've seen this evening, very, very good ones. And the one I chosen of his was the solar picture, because as a solar photographer myself, I know contending with magnification, focus problems, and the Earth's atmosphere, the sun, is a very difficult subject.
It is indeed, and take great care. His prize is a copy of the book, Astronomer's Stars.
Now, prize number 4, Graham Sinagola, for his picture of Mercury at twilight. Very much different from all of the others, which tend to be high-power pictures, but nicely observed, and the twilight can be so beautiful, as well as picking out Mercury, which is difficult.
It is indeed, and as I said, the best way to do it is to sweep around when the sun is below the horizon with a pair of binoculars. So I think it may be rather appropriate to give us a prize this time, the book Exploring the Night Sky with Binoculars.
Very good.
And we have one more prize.
Yes, a special prize, Patrick, for our youngest contributor, Michael McDade. This was a very nice picture of the moon, and we're giving him some film to encourage him to take many, many more fine pictures like that.
Well, congratulations to all those who won and commiseration to those who didn't, but we did have a stack of very good pictures, and choosing the winners was by no means easy. Douglas, what other tips have you got for aspiring photographers?
Well, if we think back to our program just a year ago, Patrick, it really depends on the equipment one's using, and you can do so much with relatively straightforward photographic equipment. Just add a drive of some kind, as you were mentioning earlier on, and you can get pictures like this. It's a photograph of the southern part of the Milky Way through Sagittarius, taken during a trip to Tenerife sometime last year. And the only thing really you need here, which is at all out of the ordinary so far as photography is concerned, is to be able to drive the camera so that you don't trail the stars, of course.
What exposure was that?
That was for 6 minutes on a driven camera at f2.8 with a fast film, 1000 ISO.
And those, of course, are the lovely star clouds that hide our view of the actual center of the galaxy.
Very much. Another type of picture we can get is the zodiacal light, a time exposure again. Zodiacal light is sunlight reflecting back off interplanetary dust. It's an evening object in the northern hemisphere during the spring. It's a morning object during the autumn. Photographically, very little problems indeed. Fast film, maximum aperture, say 2.8 or even faster, 15 minutes or even longer if you want to, and the zodiacal light can be seen very, very clearly indeed.
The trouble being, of course, you've got to be well away from artificial lights.
Well away from artificial lights, dark a sky as possible, and to be able to recognize it. I think many people, when they go to the tropics, Patrick, probably think they're seeing twilight,
yes,
but they're seeing the zodiacal light. Now, another subject arising from our previous program, satellites, and recognizing them and taking notes as well. Here's a picture of a shot which I got of, if you look away, that's Corvus in the left-hand side of the picture in the southern hemisphere sky. If you look across to the right, you can see a small bright trail. That was Pagios, which was a satellite which was launched in the mid-60s, disintegrated in the mid-70s. It was a balloon satellite. Now, this is a very large segment, which is very bright. I didn't see this at the time, but Russell Everest at the Royal Observatory in Edinburgh, of course he was a satellite specialist, identified it for me, and his job would have been a lot easier, in fact, if I kept very good notes, which I didn't do. Now, two more pictures, Patrick, to demonstrate, I think, what we can call the celestial equator, the celestial geometry of the sky. The first one is, once again, of our dear old friend Orion. The celestial equator runs through the middle of Orion. Now, if you look to the top half of this picture, you will see how the stars curve upwards to surround Polaris, as it were. Down beneath, they're curving the other way towards the southern celestial pole. And a second picture, which, of course, is as easy, if not easier. Anybody could take a picture of this kind. Of course, it's the Polaris surrounded by the trails of the stars going around it. And it's very straightforward indeed. Don't want too fast to film because you'll build up sky glow. But that one was for half an hour, incidentally, in a very good sky.
And, of course, we have the comet.
Yes, indeed. And we were talking again last year, Patrick, about the way in which film manufacturers are helping us by getting us faster and faster films. Well, a new one's just been introduced by Konica at 3200 ISO. This was a picture of our comet, Bradfield, taken just before Christmas when it was above Delphinus. That was just 10 seconds exposure with an absolutely standard camera, just a 10-second exposure.
It shows what can be done. Well, Douglas, thank you indeed for helping us judge these pictures. We're very grateful to you indeed, and let's hope that other people are encouraged now to turn their cameras to the sky and obtain photographs of the same kind. So, Douglas, thank you very much. And finally, since it's January, it's newsletter time. And if you'd like our latest newsletter, then, as usual, please send your stamped addressed envelope to Newsletter number 28, The Sky at Night, BBC Television, London W12 8QT. And then we'll send you your newsletter. And once again, very many thanks to all those of you who sent in pictures. We hope you've enjoyed the program. And when I talk to you next month, I'll be saying a good deal more about the two brightest planets on view now, Venus and Jupiter. And so until then, from Douglas and myself, good night.